Welcome all for this multiple choice questions of worm and worm wheel. I am Dr. Kulkarni from MCQ Institute. As 14 marks MCQs are compulsory for our university examination, so let us focus on this MCQs on worm and worm wheel. First MCQ related with worm and worm wheel. In case of worm, we know that worm gears. The first MCQ is worm gears are widely used when 4 options are given here. Velocity ratio is high, space is limited, axis of shafts are intersecting, and all of the above. Now, as we know that particularly spur gear velocity ratio is 6:1 or maximum 10:1. In case of helical gear also 6:1 and 10:1. In case of bevel gear, that is 3:1 or 1:1. In case of worm and worm wheel, velocity ratio is very high, and it may be 70:1. At most it may be reach up to 100:1 also. So velocity ratio is high in case of worm and worm wheel, that is correct. Second one, when space is limited, the priority is given to worm and worm wheel, because due to this high velocity ratio, in case of 100:1, this reduction in velocity, if we use the spur gears, then at least we will require the 3 stage in spur gear, helical gear, but in worm wheel, in first stage, in one stage only we can transfer this particular amount of velocity with this velocity ratio. So with less space, this is possible. So these two options, A and B, both are correct. Axis of shafts are intersecting. So when shafts are intersecting to each other, we are going to use the bevel gear, because in case of bevel gear, we know that for intersecting maybe less than 90, more than 90, or equal to 90, bevel gears are used. So these two options are correct. Velocity ratio is high, space is limited. So answer A and B. Second question is, the number of starts on worm depends upon. 4 options are there: speed of the worm, speed of worm wheel, velocity reduction, and number of teeth in worm wheel. So here we will observe that number of starts on the worm depends on speed of the worm, speed of the worm wheel. Both are different thing, but velocity reduction means, if we see the I, velocity reduction, I is equal to Z2 upon Z1. Already this particular ratio in terminology we have seen that reduction ratio or transmission ratio, I is equal to Z2 upon Z1. So Z1 is the number of starts, and number of starts on the worm gear, that is dependent upon the velocity reduction. What amount of velocity we have to reduce, based on that the number of starts on worm that are decided. Is it okay? The speed of worm wheel, that are irrespective of this number of starts, because I is mainly important in case of ratio Z2 upon Z1. So number of teeth on worm wheel, that is also not related with the number of starts. This is independent, but velocity reduction is required. So let us come to next MCQ here. So this MCQ third, if the lead angle of worm is 6 degree, then the helix angle in degree will be. This is the question. In this question, we are observing this. We know that lead angle and helix angle both are, the addition of lead angle and helix angle is 90 degree. Already we are familiar with this lead angle and helix angle. The ratio lead angle gamma plus psi, we know that is equal to, this gamma plus psi is equal to 90 degree. So that's why this we know we will have to use gamma plus psi is equal to 90 degree. The question is asked here. In the question it is asked that if lead angle is 6 degree, then what is the helix angle? So 6 plus this psi is equal to 90 degree. Obviously this psi helix angle is 84. That's why answer is A. Next question is, a pair of worm gear is designated as. So here 1/30/10/8. Which of the following statement is correct? This is the MCQs for 2 marks. More than 2 statements are correct here. Out of which first is the center distance between worm and worm wheel is 160 mm. Center distance between worm and worm wheel is 124 mm. Module is 8 mm and module is it may be 10 mm. Is it okay? So here if we observe this particular way of representation of terminology, then this is Z1, Z2, Q and M. This is the way to represent Z1, Z2, Q and M. And if we are observing this particular center distance, then center distance is 1/2 always D1 plus D2. Always we know that center distance is equal to 1/2 D1 plus D2. And particularly D1 is equal to product of Q into M. So product of Q into M, this will be D1. And D2 is also, we know that in case of this module M we are considering D2 upon Z2. So M is equal to D2 upon Z2. So D2 is equal to M into Z2. So here M into Q. So D1 is equal to M into Q and here it is M into Z2. So module which is given here Z1, Z2, Q and M is equal to 8. So this D1 will be Q into M, Z1, Z2, Q, M. So this Q into M, this is D1. So Q is equal to 8 and M is equal to, so Q is equal to 10 and M is equal to 8. So 10 into 8, that is 80. And secondly, Z2 into M means 30 into 8. This is 240. So 240 plus 80, that is equal to 320 and half of that. So that is 160 mm. So center distance between worm and worm wheel is 160 mm. That is correct. Is it okay? So with this terminology, we can identify that center distance between worm and worm wheel is 160 mm. So this A is correct. Second B is false, not correct because this 124 is not correct answer. Module is 8 mm. So because Z1, Z2, Q and M with reference to terminology M is 8. So module is 8 mm. So this D is module is 10 mm. So this is not correct. Here this is print mistake. So this is 10 mm. So C answer will be A and C. This is correct answer. Next, come to next MCQ here. Lead angle, the length of root of worm wheel depends upon. So length of root of worm wheel. So for that, number of starts, effective phase width, clearance and speed factor of worm wheel. So length of root, for this if we observe the formula, then we will come to know that length of root LR is equal to dA1 plus 2C sine inverse of F upon dA1 plus 2C. So this means that this particular length of root that depends upon addendum diameter, clearance, this particular effective phase width. So these three terms are there: addendum diameter, clearance and phase width, on which length of root of worm wheel depends. So that's why number of start, this is not correct. Effective phase width, that is correct. Clearance is correct. Speed factor, that is not correct. So B and C. So for this question number 5, answer will be B and C. Next, question 6. Inside that the worm wheel should be. So in that worm wheel should be, 4 options are given to us: embeddable, conformable, hard and conformable, hard and embeddable, none of above. So embeddability and conformability. So this means that if any small particle is dipped inside any material, then this will absorb the small particle. And conformability means this will change the shape of that particular material. This material is having characteristics that this will change its shape according to force application or shape of the meshing teeth. So worm wheel, that should be embeddable and conformable. That is the correct answer, because if it is hard, then worm wheel will make scratches on worm, and due with less period of time, this worm wheel will have to replace. That's why hard property of the worm wheel, that is not expected. Worm wheel should be conformable and embeddable. So with reference to worm, because it is advised that if situation comes, then worm wheel we can replace, but worm is not replaced, because worm is very costly to manufacture, very precise to manufacture. So that's why worms are always more precise than worm wheel. So that's why embeddability and conformability, that is required in case of worm wheel, not for worm. Let us come to this, the effective length. Before that, worm gearing is used for, if we observe same question which is repeated here, that is when space is compact and when velocity ratio is high. Here also, if lead angle of the worm is 16 degree, then he will, once again we will see that gamma plus psi is equal to 90 degree. If it is 16 degree, if this lead angle is 16 degree, then psi must be 90 minus 16, and that's why answer is 74. So C is correct here. Then coming to this ninth question, the effective length of the root is required in the analysis of. Obviously, the effective length of root. So root concept is not present in spur gear or in helical gear or bevel gear. Root concept is only associated with worm and worm wheel. So that's why correct answer is option C, worm gear. The effective length of the root is required in the analysis of worm gear. And coming to this last question, in a worm drive, the axial pitch of the worm is, and options are equal to circular pitch of the gear, equal to half the circular pitch of the gear, equal to twice the circular pitch of the gear, and none of the above. So in normally, it is considered generally that axial pitch of the worm is equal to circular pitch of the gear, because axial pitch is travel in axial direction and circular pitch is the travel in circular direction, or we may consider both should be same, axial pitch and circular pitch. That should be, so axial pitch is for worm and circular pitch is for worm wheel. So when worm wheel rotates, then this is circular motion, and when worm rotates, then this is axial motion. But the axial pitch of the worm is same as that of circular pitch of the gear, because based on this assumption only we are identifying different terminologies. Okay, so worm and worm time, axial pitch the worm is equal to circular pitch of the gear. So that's why option A is correct answer in case of this question. Okay, so this is about few MCQs on worm and worm wheel. So there may be few MCQs based on force analysis. So with this concept of force analysis, if it is clear, then we can solve. The MCQs will be asked on terminology, geometrical relations, force analysis, and in general velocity ratios, etc. So let us try to answer these questions properly. Thank you.